All right, we are ready for our next section titled Adding and Subtracting Rational Expressions. Now, obviously, we're going to add and subtract these fractional expressions. The only difference is it was with fractions previously in elementary school. Now we're dealing with these polynomial-looking fractions, but we want to use our same rules. So, if we remember how to add and subtract with regular fractions, we should be able to add and subtract with these new polynomial or rational functions. You must have a common denominator to add and subtract. You hopefully remember that. Find the common denominator and multiply by the missing factors, only when needed, because some of them, that might be the common denominator, so you only have to change one of the fractions. And then add and subtract the numerators, keeping the denominator the same. And as an example here, if I just did normal fractions, I'd be looking at 3/5 plus 2/7, take away 1/2. I'd be saying, what is a number they all go into? And so you start sometimes with the highest number, because 5 doesn't go into 7, 2 doesn't go into 7 evenly, so 7 times 1, 7 times 2 is 14, doesn't work. 5 and 2 don't go into both of them. 7 times 3 is 21, 5 doesn't go into 21, 2 doesn't go into 21. 7 times 4 is 28, nope. 7 times 5 is 35, 5 goes into it, but obviously 2 doesn't. So it looks like we're going to get 70 if we continue that process. So 70 is my number. We would have to multiply this first one by 14, the middle one by 10, and the last one by 35 in order to get that common denominator of 70 on all three fractions. Okay? Once we did that, we'd have new numerators. We would add and subtract the numerators as designated. But since we're supposed to be really good at fractions already, let's move on to these rational ones and show you what they're going to look like. All right. Remember, you must have a common denominator. So really you're focusing on the denominators. And right now, I'm going to lock this one in. We've got an x plus 6. It's a binomial that can't be factored. But over here, this binomial can be factored. So right now, if I factor it, I'm looking into an x plus 6 and an x minus 6, our difference of squares. So that's gone. Our new denominator has one of each of the quantities in it. So that would be our common denominator, because you can see x plus 6 goes into it. So really this guy just needs the x minus 6. So if our common denominator is one of each, we would have to multiply this first fraction by the factor x minus 6. That means this first one will have a new numerator. So x squared minus 6x would be the new numerator. We'd still have that common denominator of x minus 6, x plus 6. I'm being lazy right now. New denominator, and we'd still have the 72. So when you start looking at what you can do, once your denominators are the same, and we do have the same denominator, we could multiply it out, but I'm going to save that for the last step. We need to add or subtract our numerator. So what is x squared minus 6x plus 72? And our rule has always been with polynomials, only add and subtract the like terms. So we are going to get x squared minus 6x plus 72. And it's all over an x plus 6, x minus 6 factor combination. Now, up on top, you could try to factor it and see if we can go lower, so like lowest terms once we have this fraction. So I'm going to work above it right now. If we factored that, we'd be looking at, it looks like an x minus 12 and an x plus 6. So I leave it in factored form to help me factor or reduce the fraction, and now I am seeing a lowest terms, because an x and 6 and an x minus 6. So our lowest term final answer would be the quantity of x minus 12 over x minus 6 as we finish. And that's just because the fraction had like terms in it, like factors, and that means it wasn't in lowest terms, and we could reduce it further. So now it's in lowest terms, and we are done. Next example. This one starts out a little differently. It looks like, again, we focus on the denominators, and we can factor both denominators. If we take a 3 out of the first term, or both terms here, we would have the quantity of x minus 1 as our new denominator. Over here, we have an x squared minus 1, which we should recognize is a difference of squares. And the difference of squares means what factors into 1 plus quantity and 1 minus quantity. And so that's now gone. So we start looking at them and saying, oh, what do we have in common? Well, it looks like when we finish here, we're going to need a 3. We're also going to need a minus quantity, and we're going to need one of those plus quantities. So our common denominator is really going to be made up of those 3 factors. So now look at the 2 that are there originally and say to yourself, what's missing? What do we still need in order to get that common denominator? And in this first one, it would be the factor of x plus 1. Okay? So you can then see our denominator is complete. We'd still have to multiply out the top, so we can do that now. X squared plus x. On the second fraction, when you say what's missing, to have a 3, an x minus 1, and an x plus 1, it's the factor of 3 that's missing. So we'd have to multiply, and we would get a new numerator of a 3x. So looking at what we have, the rule is now, once you have a common denominator, just add the numerators. We would get x squared, then plus 1x, take away 3x, should leave us a negative 2x. And again, that common denominator is still there. When you add like fractions, they do not change. When I add fourths with fourths, they stay fourths. We want to double check on top, though, again, to see if we factor this out, if we can reduce. So my factoring here is I see a common factor of x. So I factor that out, and I get x minus 2. If I'd rename that top, but I look at the bottom there, and I don't see anything that would cancel on. So really now, most of your answers are going to be polynomial form. All we would have to do is finish multiplying this back out, and the x squared minus 1, the x minus 1, x plus 1 would turn into x squared minus 1. If we multiplied it by 3, so let's move this up a little and see our final answer on this one should be that x squared minus 2x in the numerator all over that 3x squared minus 3 in the denominator. So that would be our answer on this one. There was nothing to reduce or allowed us to reduce on this. All right, let's go one more step further, and this is basically that you have a, let's put our check answer back to where it needs to be, and that would just be let's check it. We'll check that after we're all done. So, on this one you're seeing we have a complex number inside of our fractions. So I think the first deal is we need to rewrite those denominators and start thinking. So look at just this denominator right now and saying, that's a whole number in a fraction anyway, so we need a common denominator. So that common denominator is going to have to be the a. So right now it's a 1, so we're going to have to multiply both top and bottom by a. So we'd very quickly have 3a plus 5 all over a. Right? And on this side, same thing. Think of it as a 1. So we'd have an a, we'd get a 3a minus 5 all over a. So you know in division, which is what we're looking at right here now, you multiply by the reciprocal. So if I took 2 times 2, which is on top, 2 times 2 divided by 3a plus 5 over a, that'd be 2 times the reciprocal, and we'd write it like this to simplify, and our new fraction would be 2a over 3a plus 5. Same thing here. This would have been a 2 on top divided by times, though, the reciprocal would be a over 3a minus 5. So the fraction of 2a over 3a minus 5. So right now we have just these two fractions remaining. They are not common denominator. They're very close. So again, you're asking yourself, what do I need to make them a common denominator? And it looks like we're going to have one of each of those quantities. It's not just a quick trick with a sign or anything like that. So 3a plus 5, 3a minus 5 is going to have to be our common denominator. 3a plus 5, 3a minus 5. And now ask yourself what's missing. Over on this side, it's the 3a minus 5. I'm doing work over work, I realize, but that's okay. 3a plus 5 on this side is what we needed. We already got the bottom set, so we really don't have to worry about those. They're written down here. But the top, we got to multiply out. So 2a times 3a, 6a squared. 2a times a negative 5 is negative 10a. Over here, take the 2a and times it by our numerator. So 6a squared. And 2a times 5 is 10a. And again, lastly, put your subtraction sign back in and look at what you have remaining. Common denominators are good. Let's use a little of our space up here that we have remaining. If I subtract 6a squared minus 6a squared, gone. Negative 10a minus 10a, I believe, will give me a negative 20a. And our denominator, we can multiply back out, would give us 9a squared minus 25. So final answer, and we can check, and I think we saw that to begin with. There we go. It matches. So you're going to get a little practice in working with these fractions today. Definitely need them. Common denominators are big in what we're going to be doing later on in the chapter. So a little practice, and you should be good. Bring any questions you have to class.